Hello. In the previous lecture in our chemical reactions series, we discussed how we categorize reactions by looking at the type of chemistry or phenomena that occurs during the reaction. Now, the three general reaction types are precipitation reactions, acid-base reactions, and reduction-oxidation reactions, or in short, redox reactions. We're now going to unpack these reaction types and look at each one separately.
The first reaction type we will look at is precipitation reactions, where we mix clear, not colorless, just clear solutions, usually containing dissolved ionic compounds, and when combined they form solids called precipitates that fall out of the liquid. Now, if a precipitate doesn't form, we assume no reaction occurred. For simplicity, we're going to limit the reactions to aqueous or water solutions. Now, how this works is that two different aqueous salt solutions are combined in a beaker, and a double displacement reaction can occur. Now, if one or both compounds produced in the double displacement are insoluble in the water, then they will fall out of the solution and form a precipitate. Now, we have to be very familiar with the solubility rules for common ionic compounds in water if we want to be able to predict if a reaction has the chance of occurring, or if we should expect a reaction at all. So let's say we combine a potassium iodide solution, which we know is soluble since all potassium ion compounds are soluble, with another soluble salt, lead 2 nitrate. Again, we know that all nitrate compounds are soluble. Now, if a double displacement reaction were to occur, the final products would be potassium nitrate and lead 2 iodide. Now, we use our solubility rules to figure out if one or these two products will fall out of solution. We know that all the potassium cation and nitrate salts are soluble, so potassium nitrate will remain in solution. Now, as for the lead 2 iodide, we know that all halogen ions are soluble except for those with lead. So lead 2 iodide is insoluble and will fall out of the solution. So we expect to see a precipitate reaction, and the balanced equation follows. What a cool reaction, right? The lead 2 iodide salt is a bright canary yellow colored solid that is pretty startling when it forms. Now, for aqueous solutions containing ions, there are two other ways we can write the reactions. We know in truth that the aqueous form of soluble salts is as separated ions that are solvated by many water molecules and held apart by ion dipole forces. The version of the equation that reflects the chemistry and includes a more realistic idea of the separated solvated ions is shown. We call this way of writing a chemical reaction a complete ionic equation, where we show every ion in the solution. Notice the aqueous potassium ion and nitrate ion, though, both show up on both sides of the equation. They're not participating in the chemistry, so we call these non-reacting ions spectator ions. Just as in a math equation, if we take these ions out of the equations, that shouldn't change the fundamental equation at all. So if we eliminate the spectator ions from the complete ionic equation, we get the following reaction equation. And this type of equation is called a net ionic equation, and just includes the ions that take part in the creation of the precipitates. One thing I want you to notice here, the total charge on both sides of the equation, as well as the number of atoms, is balanced. Okay, let's do another example. We're going to take two water solutions, one lithium nitrate solution and one sodium sulfate solution, and combine them into a single beaker. Will we see a reaction? Again, we will assume a double displacement will happen. The possible products would be lithium sulfate and sodium nitrate. Both possible product salts will be soluble, though, and stay in the solution according to the solubility rules, which state that all lithium and nitrate compounds are soluble. In effect, no reaction takes place because no precipitate forms. Another way to think about it is that if we wrote the system as a complete ionic equation, all the ions are spectator ions, and no net ionic equation would exist.
just 2 more reaction types to learn about. We'll catch you in the next videos.